Okay, welcome Amberly and Paige and Lamar, and hopefully we'll get a few more coming in. This is the week 4 webinar, and the plan today is to talk about the normal distribution, which is the most important distribution, definitely by far, than any other distribution that there is. In fact, it's so important. Any of you happen to go to Google today? Do any kind of search and look at their page and see their little doodle?
Yeah.
Do you notice anything?
It's big and colorful.
Maybe I'll show you. I think I'm going to share it because it's like pretty cool. It's just like total coincidence. So let me share my desktop so I can tell you how important this normal distribution really is.
There's a graph on it.
Yeah, so let me, what was it? There it is. So this is just Google. I'm not going anything other than Google. And you see the little, what they call the doodle? And you might notice it's not just any old graph. Any guess on what this graph is?
A normal distribution.
This is the normal distribution graph. And it's the birthday of Johann Carl Friedrich Gauss. The 241st birthday. Obviously, he's not alive anymore. But he's the one that came up with this normal distribution. And I was like shocked. It's like this morning, the day I'm going to be talking about the normal distribution, there it is. Google is putting the normal distribution on their main doodle. You know, how lucky is that? So it's important. The normal distribution is important enough that Google has decided today is the day of the normal distribution. But Gauss did some other things too, as you might see. He was one of these super geniuses. But what we're going to talk about is the normal distribution, how to use it. We'll do a couple applications, but the main applications of this come at the rest of this course. Just about everything we do for the rest of this class uses the normal distribution. Sometimes it's a tweak of the normal distribution, but it always starts with the normal distribution. So this is the biggie. Last week we did the uniform distribution, and that was just because it's easy, not because it's important. It's not important at all. Normal distribution is everything, and we'll see that as we go through the entire course. Today you won't see it as much. We're just going to learn what it is and how to use it. So that's the plan of the day, is to talk about the normal distribution. And not only was today's plan, but even Google beat me to it and made it their plan too. So let me unshare my desktop, and let me note the project is due Sunday. Take the project very seriously. You should be at this point, hopefully, into your project and not like thinking about it maybe. You should actually be hopefully having your data collected and really have a good plan. I think I'm going to mute everybody here because we're getting some really bad feedback. There we go. Okay. If you want, Bella, you can unmute yourself if you want to talk, but I just want to make sure because we're getting some feedback. I just want to note the project is super, super important, and it's a big part of your grade. Unlike everything else we've done this quarter, they're all little tiny, tiny chunks of your grade. The project is a large portion of your entire grade. And it's important for learning. When I hear people talk about this class a couple years later, they all tell me the project was the most important part of the whole class for their learning and what they got out of the class. So hopefully you'll get a lot out of it also. If you don't already have a study in mind, you need to do that right away. You can look through the project discussion forum. It'll give you some ideas of what other people have done and also what mistakes people have done. And they did it early, they fixed their mistake, and now they're off to a great start. If you have any questions about the project, you can ask now. So are there any questions? And again, unmute yourself and then ask a question. And I'll be happy to answer any question you might have. Any question, or about anything else, but especially the project, because that's the big thing coming. Okay. I also strongly recommend you watch the webinar when I talked about the project. I think that was 2 weeks ago. and because I wanted to give you lots of time to do the project. And try to get your first draft done by Wednesday night, so that you can email it to me. And then once you email it to me, I'll look at it and give you advice and a whole long list of suggestions typically on how to make it better so you can have a really good grade. I want you guys to do well, but if you don't do things like that, it's really hard for me to help, because all I can do is grade whether the project is good or not. And I can help you make it good only if you get that help. But don't wait until Sunday to start the project. That would be a disaster. Okay, any questions? Any questions? Because this is the time to ask questions. There's other times too, but this is the best time. Not seeing any questions. Okay, if there aren't any, I'll go on. I'll just let you know at the end of the webinar, I answer questions again, or anytime during it. So if you come up with questions, please ask. That's kind of the whole point. All right, so let me share my screen, and we're going to do some problems involving the normal distribution. Oops, wrong one. Sorry about that. That's going to be the problem, but it's where'd it go? Uh-oh. Stop share. I know I want to share. Just a minute. One more try. Where'd it go? There it is. That's the one. Okay, so here's the question. Okay, and this is the only time in the whole class I'm going to suggest let's not use a calculator. Okay, the first couple problems. Do not use a calculator for this problem. Suppose that Z follows a standard normal distribution. So the first thing I'm going to do is I'm going to write down what that means. So what it means, first thing is I'm going to write down the letter Z. And I also want to do this, just a minute. We're way too big. Z, let's make it red, because it's that important. Z, and then tilde, and then N. What does N stand for? Any guesses?
Normal.
Yep, N stands for normal. Very important to know that. And then you put down the first number as the mean. And the mean in this case, if it's a standard normal, the mean is 0. And the standard deviation is 1 when you have a standard normal distribution. So when I ask you, if I ever ask you to write down the distribution, this is what I mean. Okay, and I will guarantee you're going to have to do this on the midterm. Write down the distribution. It won't be 0 and 1, but you need to understand this notation. We'll do this next week also. So that's just a note. I like to warn you when something's going to come up on the test. And a lot of people, I say write down the distribution, they just totally ignore it. And if you ignore it on a midterm, you guys know what happens? If I ask you to do something and you ignore it on a midterm, you lose points. And don't lose points. So make sure you know how to write down the distribution. So in this case, it's Z tilde N 0, 1. Now we want to find the probability that Z is between -1 and 1. So now I'm going to sketch it. Okay, I want to draw the normal distribution. And I know that's not perfect, but I'm just sketching it just like you would do when you draw it on a piece of paper. I don't expect perfection, but it should look somewhat bell-shaped because that's what the normal distribution is. And then what I'm going to do is I'm going to write down that center. That center should be marked as 0. Because the center of this normal distribution is 0. Then what I can do is I can write down the probability between 1 and -1 and 1. So let's do that. I need some more brushing. So I'm going to go -1 to 1. and then I'm going to shade. That's -1 to 1. Okay, and now you're supposed to know this, especially those of you who are well into the project. If you have something that's normally shaped, or even approximately normally shaped, then what is the area that has a z-score, or 1 standard deviation from the mean? You guys remember the number? It's a very special number. It's called the empirical rule. That might help. In Bell chapter 2, we did this. That's why. And you remember? Okay, I better tell you, but this is something you probably should remember, and that is 68%, or 0.68. Any questions on that? So there's our probability. Anyone lost on what I just did? Again, that's the thing you're supposed to memorize, is that 68% for 1 standard deviation from the mean, 95% for 2, and 99.7% for 3. Does that ring a bell at all? A couple of you remember it, kind of, right? Again, if your distribution is approximately normal, when you're doing your project, use it. It's a requirement. If it's not, there's something called Chebyshev's formula, and that's what you're going to use if you can't use the normal distribution. And that really, how do you tell, by the way, if something looks normally distributed on your project? What are you going to look for?
Shape.
The shape. And what's going to show you the shape in your project?
The graphs.
Yeah, and particularly which graph? Not sure? Histogram. So the histogram gives you the shape of the distribution. The box plot won't do that. The histogram will give you the shape. So you look at your histogram, and if your histogram is approximately normally distributed, then you know there's one standard deviation from the mean should contain 68%. 2 should contain 95%. 3 should contain 99.7. That ring a bell, hopefully? Okay, so now that we've done that, we can do part B. We just did part A, which is 0.68. Part B is find the probability that z is less than 3. So again, let's do a little sketch. Maybe I'll do it over here. Okay, less than 3. There's 3. And we want to find out what is the area to the left of 3. Any questions in the picture? Okay, so to do that, what I'm going to do is, we don't know that. We only know between -3 and 3. We don't know less than 3 automatically. So what I'm going to do is I'm going to draw, maybe in a different color, green, -3. Any questions on that? So we know from the empirical rule that between -3 and 3, you guys remember I said it just a minute and a half ago. What's that area?
0.68.
0.68 is between -1 and 1.
99.7.
Yeah, 99.7% or 0.997. Okay. Is that clear? Okay, so now the question is, how much is, if the inside is 0.997, how do you find out how much is in the outside?
1 minus that?
Exactly. So 1 minus 0.997 is 0.003. If you can't do it in your head, then do it on paper, but that shouldn't be too hard. So that's 0.003.
I'm confused on how you're getting the 0.997.
That's called the empirical rule. So whenever you're in between -3 and 3, standard deviations away, and you have a normal distribution, that's the number. Okay, so that's just one to know.
Okay.
So 68, sometimes they call it the 68, 95, 99.7 rule. That's another name for the empirical rule, just to get you to remember those three numbers. So the way you actually get it is very difficult. And very difficult you should like, because that means you don't have to worry about it. Here's a trivia question that you might know. Who got it? Who's the one that came up with it? Got the 997. Gauss, remember the Google guy? Yeah, he's the guy that did all that. And he was a super genius. So I don't expect, you're all super geniuses, but I'm not going to make you do that. Even if you all can, you can just pretend you can't. How's that? Okay, but it's really, really hard. Okay, but you should have it memorized or have it on paper somewhere. Okay, so now the problem is that we don't want both sides of that because we want just the left side. So if you combine the left side and the middle part, you'll get what we want. Is that clear? How do you get just the left side if you know both sides is 0.003?
Divide by 2.
Yeah, divide by 2. So what we can say now is that just the left side is 0.0015. 30 divided by 2 is 15, right? Any questions on the little geometry there? Okay, now we want the total area to the left of 3. So what we can do is we combine those two. How do we combine them?
Add?
Yeah, we add them. So the answer to part B is 0.997 plus 0.005. Okay, and that is, I might as well write it in. That's going to be 0.9985 when you add those two numbers. Any questions on that? All right, so I think I'm going to skip part C. Part C is pretty similar. You combine things and do the same old stuff, but I'm going to go to D because D is very different. So find the value of Z such that there is a 2.5% probability of being greater than this value of Z. Okay, so I'm going to start just like I did last time. And that is with a sketch. I was going to do it in blue, but accidentally did in red. That's okay. So there's our sketch. And that's 0. And then I want to find the probability. We know that the probability of being greater than this value is 2.5%. Okay, so if 2.5% is bigger, do you think the value is going to be far left or far right or close to the middle?
Right.
Yeah, it's far right, because if only 2.5% of the population is taller than you, you're tall. Does that make sense? So same idea, if only 2.5% is bigger than you, you're far to the right, because right is big. So what I'm going to do is I'm going to put over here, and I'm going to shade that in, and the area is 2.5%. I'm going to write that as a decimal, because when you do math, it's better to have decimals than percents. 2.5% is 0.02 0.025. A lot of people make that mistake and forget to move the decimal over twice, but we need to. 0.025. Any questions on that? And when we don't know a number, give it a name. How about Z? Okay, then we're not quite ready yet because that doesn't like ring a bell. There's no special number 0.025. So what I'm going to do now is I'm going to go to the mirror image over here and say that's 0.025. One thing about the normal curve is it's symmetric. And that's negative Z. All right, so how much total is in the outside?
0.05.
0.05. So if there's 0.05 on the outside, how much is in the inside?
95.
95%, right? If you have a 5% chance of winning, you have a 95% chance of losing. Because look at it that way. So this guy is 0.95. Any questions on that? All right, so now that we know that, we can just answer the question. What's Z?
2.
Yep, 2. Because the empirical rule says 95% is between -2 and 2. So the answer is 2. That is 2. Any questions on this question? All right, I think I'm going to skip E and go to F. And I'll do a couple of Fs. Find the Z-score for the values 1.3, et cetera, et cetera. You guys remember the formula for the Z-score? And remember?
Oh, is it x minus mu over the standard deviation?
Beautiful. X minus mu over sigma. So that's a Z-score formula. One of the things I like about this is we can do a lot of review while we're doing the new stuff. And the Z-score is review. Now if we go up, I wrote down what the mean and standard deviation are. What is mu and what is sigma? So what's mu? What's the mean?
0.
0, because it says so. And what's the standard deviation?
1.
1. So that means we can just plug in. So for 1.3, you get 1.3 minus 0 divided by 1. Now, you don't need a calculator for that. What's 1.3 minus 0 divided by 1?
0.3.
1.3. Any questions on that? All right, what do you think the Z-score is for negative 4.5?
Negative 4.5?
Yeah, negative 4.5. It's negative 4.5 minus 0 divided by 1. Okay, that is the reason why we use the letter Z for standard normal. It's because it is its own Z-score. Any questions on that? Any questions?
So the 0 and 1 is just, that's for every normal distribution?
No, only if it's a standard.
Oh, standard normal. Okay.
Yeah, as we'll see in a minute.
Okay.
Now we're going to do the next one, which is not going to be standard. So so by the way, last chance if you don't want it erased. Gone. Okay, let's do the next one. And it's going to be similar, at least the first bit, and that is don't use your calculator. Okay, so do not use your calculator for this problem. And I don't know if we'll do all of them, but we'll do some. Suppose X follows a normal distribution with mean 35 and standard deviation 9. So hopefully that answers your question, that the mean's not always 0 and the standard deviation is not always 1. Only when you see the word standard normal. Okay. Part A is find the probability that X is between 26 and 44. So what I can do, same idea, is I can draw a normal curve. Okay, now the mean is 35. Any questions on that? We want to see, is it between 26 and 44? So 26 is going to be over here. And 44 is going to be here. And I can shade in. Any questions so far? All right. Well, we can't use a calculator, so we need to do this in a smart way. And the smart way to do this is to use z-scores. So let's find the z-score for 44. So to do that, you go 44 minus 35 divided by the standard deviation. And by the way, let me write down, this is important, x tilde n, and now we're 35.9. Any questions on that? So from that, that's why we're subtracting 35, we need to divide by 9, and tell me what you get. You probably don't need a calculator for that.
1.
It's 1. Okay, let's do the same thing with 26. What if we do 26 minus 35 divided by 9? What do you get?
Negative.
-1.
That's -1. So now we can answer the question, because we're looking at z between -1 and 1. What is that probability?
68%.
Yep, 68%. So the answer to part A is 0.68. Any questions on that? Okay, I'm not going to do all of these. I want to make sure that we have time to do some calculator stuff too. I think I'll do one more, and I'll do one on the other side now. Let's find the 84th percentile. Let's do part E. So to find the 84th percentile, what we do is the same thing that we've done in all of these. Start out with a picture. Any questions so far? Now the mean is 35. Do you remember what 84th percentile means?
Isn't it like 0.84 is below the value?
Exactly. So that means I'm gonna, if 84% is below, then you're pretty big, right? So that means if I shade in like so, that is 0.84. Any questions on that? Okay, so if that's 0.84, how much is the other side?
0.16.
0.16. Any questions on that? All right, so if that's 0.16, then what we do is we still got to make sense of it. And I always believe in drawing the symmetric picture. Let's draw over here and put a 0.16. Okay, and also let's put an X right there. How much is in between this little green line and this red line? How much is outside of it first?
Outside 32, inside 0.68.
0.68. And at that point, you're supposed to smile. Why should you smile?
Because X's z-score is 1.
Yeah. So that means the z-score is 1. So that's 0.68. So that means X is equal to 1. Anyone lost? Anyone lost? I want to give you a warning. This is a lot easier to watch than to do. Do you agree? Coming up with yourself is a lot harder than to do it than to watch me do it. Okay. Now we're not done yet. Okay, because that's not really X. That means a Z is 1. So really, I'm going to say X is question mark still. If Z equals 1. Because the Z-score is 1, not the X score. So then what we can do, we could either do it because we just did it, but I want to show you just in case so you know how to do it if you didn't just do it. Then we say Z is 1, and you go equals X minus 35 over 9. Any questions on that? And then it's basic algebra. Multiply by 9, add by 35, and you'll end up with 44. Any questions at all? Any questions? Okay, so let me go to the next one. Speak now or it will be erased. All right. So now it says use a calculator for this problem. Okay, most people like that when they get to use a calculator, but I'll show you how to do that. Suppose that X follows the normal distribution with mean 114 and standard deviation 23. So let me just write down, because it's very important that you know how to do this, is X tilde n 114 comma 23. Any questions so far? That's the distribution. That's writing down the distribution. Okay, now for part A, we want to find the probability that X is between 100 and 120. I will require you to sketch it. So we need to be able to sketch, and hopefully you guys can. We have a normal distribution. The center of that is 114. And we want to see between 100 and 120. that's an awful 120. All right, that's 120. And I'm going to shade. Any questions so far? Okay, so now what I need to do is I need my calculator. So let me show you what to do next. So now I'm going to go ahead and share my calculator. And what we're going to do is we're going to go to second distribution, that VARS button. And the good news is it's right there, normal CDF is what we need. And I want to let you know there are two types of TI-84 calculator. Drives me crazy. This is one type where it asks you lower, upper, mu, sigma, and then paste. And the other type, it doesn't ask you anything. It just puts it in, and you just type in your lower, comma, upper, comma, mu, comma, sigma, and hit enter. All right. So what was the lower?
100.
Yep. So 100. What was the upper?
120.
Yep. What was mu?
114.
Mm-hmm. And what was sigma?
23 or something?
Yep. 23.
You didn't type 120 on the upper.
Sorry. I know that sounds weird. I did type it, it just didn't read it. 1, 2, 0. I just didn't hit it hard enough. Sometimes that happens with this program. Sorry about that. And then paste and hit enter one more time. And about 33%. If you're doing it on the computer for your assignment, you'll write 0.3315 because it's going to ask you 4 decimals. Any questions on that? Do you like doing it with a calculator?
My calculator doesn't have that. It doesn't list it out.
Yeah, if it doesn't list it out, do you see what's up there on the screen now? Normal CDF 100, comma, 120, comma, 114, comma, 23, and the paren? Do exactly what that says, and then it'll work.
Okay.
Yeah, so instead of listing, the old calculator is a little quicker, but not quite as easy to remember. There's a little less typing for it, but it's harder to remember.
Okay.
And you got it? Okay, so that's it. About 33% or so. All right, so let me go back to the next one or another one. Let me, that one. All right, let's find the IQR. So part E. What does that mean, IQR? Do you remember?
Inner quartile range.
Yeah, the interquartile range. So which means when I draw a picture, by the way, you're all going to get good at drawing this picture. You're going to be drawing this picture on the exam. I will definitely ask you to draw this picture on the midterm. So when you're doing it on homework, make sure you have a piece of paper and pencil and draw the picture. Because most of the problems don't like you physically ask you to draw a picture on a computer. I think one of them might actually. But make sure you do it on every one of them. And same thing, get the distribution drawn. Okay, so we have the interquartile range. So if you remember, that was Q1 to Q3. Do you remember that? So Q1 means that 25% lies to the left of that value. And I'm going to write that as Q1. Any questions so far? Okay, Q3. How much lies to the left of Q3? Do you remember?
70, is it 0.75?
Yep. 75% lies to the left of Q3. Any questions on that? So now we need to find Q1 and Q3 with our calculator. And we're going to use the fact that it's normally distributed with mean 114 and standard deviation 23. We need that. And it's actually easy to do if you know how to do it. So let me show you. Okay, so I can clear what I had. So now what I'm going to do is I'm going to go second distribution, just like before. And then I want to note something. See this normal PDF, which is number 1? If you ever use this in this class, you blew it. Okay, that's never going to be used in our class. So unfortunately, I don't know why they put it number 1, because it's definitely not the most important. The most important is definitely normal CDF. The second most is this inv norm. Now in math, when you see inverse, what should you be thinking?
Negative?
What's that?
Negative?
Not always negative. For example, the inverse of f of x equals x cubed is x to the 1/3.
Reciprocal?
Reciprocal, but it doesn't always work that way either. Okay, you should be thinking of going backwards, because that's what inverse functions do, right? So regular functions go from here to here. Inverses go from here back. Do you remember doing that in algebra? I know y'all love algebra so much, but you did it in algebra. You did inverse functions. So what this is we're going backwards, right? In the first problem that we did, we were given values of x, and we wanted to find area. In this problem, we're given area, and we want to find the value of x. Is that clear? So we're going backwards, and that's why we're using the inv norm, because it's a go backwards kind of problem. So I'm going to hit enter on inv norm, and let's do Q1 first. So the area is 0.25. Mu was 114. Sigma was 23. And most of your calculators won't have this. Only the newest type have this. But the tail I'm having is left. And then I hit enter. And then I hit one more enter. Any questions so far? Okay, now I do the same thing, except I'm going to do it with 0.75. I'm going to show you a little trick with this calculator. If I go second entry, it gives me what I had. And then I can go ahead and make that a 7. Isn't that tricky? You don't have to do it that way. You can go back with the inv norm and then go to 0.75 and hit enter a couple times. This is a lot faster though. Then I hit enter one more time, and we get about 129.51. So now, remember the interquartile range is the difference of the two. So now I can type in 129.51 minus, and then we have 98.49. And you get 31.02. Okay. On the assignments, by the way, you do however many decimals they tell you. If they tell you 4, do 4 decimals. If they say whole number, do whole number. Is that clear? Okay, so I decided to do 2 decimals just for fun. Any questions? Any questions on this question? Okay, I think I'm going to do another problem. So I'm going to get rid of this. I'm not going to do all the rest. I always have a bunch, and then I don't do them all. just in case we decided to go fly and go super fast, but we don't need to do that. Okay, so the next problem, it's a fun one. I always get some interesting answers on this one, so we'll see what happens. All right. So now we got a little word problem. So suppose that the time until you, or your wife if you're male, obviously, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. By the way, time of giving birth naturally is actually normally distributed. And mean 140 days, what is that? What is that in terms of like everyday English?
Nine months.
It's not 9 months actually. 9 months is like 270-ish days. Okay, that's your expected date, right? When they say when are you expecting, that's what that means. It means your average amount of time that it's going to take before you have the child is 140 days from now. So if you ever get pregnant or if you ever impregnate someone, I see about half and half here. Everyone will ask, when's it due? That's the due date. Okay, and it turns out 7 really is about the standard deviation for human births. Okay, it's kind of coincidentally a week. Okay, and that's for natural birth. All right, so now here's the problem. Your boss has just scheduled you, or your wife, if you happen to be male, for a business trip to China. Okay, do you think that's a good thing if you're pregnant? Probably not good, but you're not due for 140 days, right? Okay, you're going to leave today, and you're going to return in 135 days. Sound good? Okay, maybe not a good idea, but we'll see. Find the probability the baby will be born in China. Any questions on the question? All right, so now what I'm going to do, same thing I've been doing all along, is I'm going to draw a picture. Whoops, what just happened? Let's try again. Now let me draw a picture. So I'm going to draw a picture. What should I put right in the middle here?
140.
Yeah, 140, because that's the mean. And in fact, I think it's a good idea always. I'm going to write down x tilde normal, so n 140 comma 7. All right, so if it's born in China, that means it's born sometime between now and day 135. So here's day 135. And now is basically the edge. It's so many standard deviations away, we can just call it negative infinity. Okay, any questions so far? And the probability will be that area. Is that clear? So now I go ahead and let's go to our calculator, because we need our calculator for all of these now. We're done, by the way, with any problem that says don't use your calculator. That'll never happen again in this class. Okay. Sometimes I tell you don't need one, but you can always use one if you want. So let's use a calculator. And what I'm going to do is I'm going to go second distribution, normal CDF, because we're given numbers and we want an area. The lower now, I'm going to type in negative. You could do 0 if you want, actually. That's probably even better. I'm going to go 0 in this case because 0 means that it just got born now. Okay, probably wouldn't happen. Okay, definitely wouldn't. The upper was 135. Mu was 140. And sigma was 7. I hit enter and enter again. Okay, so about a 24% chance. So what do you think? Go to China or not?
No.
Yeah. For all of you men out there, you go to China, you're not going to have a wife anymore. For all of you women, you go to China, you could have a nightmare of dealing with this whole citizenship stuff, and your kid can't be president if it's born, and all kinds of issues when it's born in China. So you want your baby born where you are a citizen of. It's a very smart thing, and 24% is way too big a percent. Does that make sense? All right, so let's continue reading. You decide that it's too risky. Don't you agree? Okay, so you're going to negotiate. You're going to go negotiate with your boss. Okay, you don't want to quit your job. Okay, you still have to get to China, but you're going to negotiate with your boss to make sure that there's no more than 1% chance that the baby will be born in China. Does that sound more reasonable than 24% chance? Yeah, that's a little better. What day should you ask to be the return date? Any questions on the question? All right, so now, again, same normal curve. Like so. 140. Okay. You're going to make sure you're going to return way before day 140, not day 135. So way over here, so that this area is 0.01. We don't know this value, that's our return date. So I'm going to call it X. Any questions so far? Any questions? All right. What kind of things should we do in our calculator to find X?
Inverse norm.
Yeah, this is inverse norm because we're going backwards. We're given an area, we want to find a value, and that's inverse. So now I can go to my calculator. So there's my calculator. And I'm going to go again, second distribution. Number 3 is inv norm. The area now is 0.01. The mean was 140. Standard deviation was 7. Tails left, and I paste. And what it says, so what should you tell your boss? How many days from today do you need to make sure you're back?
124.
I would say 123. Because you want it to be no more than 1%. 124 is a little tiny bit more than 1%. You see that?
Oh, you're right. I was thinking opposite.
Yeah, this is one of those where you don't round because of the word no more. So you can negotiate with your boss and say, I need to get back at least by day 123 from now. Any questions on that? Okay, still probably a bad idea. Okay, do you really want to go on an airplane when you're almost 9 months pregnant? 8 months pregnant? Probably not a good thing. I don't even know if they let you, but so here's what's going on. We're going to cancel our trip instead. Okay, but now it's 138 days later, and the baby still hasn't been born. So find the probability the baby will be born within the next 24 hours. Any questions on that? What kind of question is this? The hint is we have to use something that we've learned before that you may not have liked.
Is it a given?
Yeah, this is a given problem. Because now we want to find out the probability that baby will be born between day 138 and day 139, given that it's born after day 138. Do you see that? So let me write that down in symbols. Want the probability that X is between 138, let's see if I'm room for that, and 139. Given X is greater than 138. Any questions on that? But that, from formula from chapter 3 now, tells you there's lots of review, which is always good. That's going to be the probability that you have both. And by the way, if it's between 138 and 139 and it's greater than 138, the greater than 138 didn't tell you anything. So that just is probability that X is between 138 and 139. Divided by the probability that X is greater than 138. Any questions on that? All right. So now the pictures, there's two pictures. There's the numerator picture and the denominator picture. The numerator picture has 138 to 139. For time reasons, I'm just going to put it over here in the middle here. So 138 to 139. That'll be the numerator. The denominator is greater than 138. Any questions on the two pictures? Okay, so now go ahead and use my calculator. Okay, by the way, you definitely need your calculator for this. So what I'm going to do is I'm going to go second distribution, normal CDF. And I want to be between 138 and 139. The mean was 140. The standard deviation was 7. I hit enter a couple times, and that's 0.05565 or so. Then I'm going to do the same thing and go second distribution, normal CDF. And now we're going to be greater than 138. So 138, not to 139, but how much? What is greater than 138? What's the high number? You don't know? High number is infinity. Okay, but calculators can't handle infinity. So what you do is you just give it a really big number, just a bunch of 9s. You always have to do a lot more 9s than the number of digits that you got for other things. And then, still 140 and 7, paste and enter. So now I divide. I go 0.05565 divided by 0.61245. And I get about 9% chance. Any questions on that? Okay. Kind of interesting little problems, aren't they? Okay, and this is somewhat realistic, by the way. It's somewhat realistic. Most people don't sit there with normal distributions to figure out what the chances are for the next day. They just kind of deal with it. But if you really want to know, this is how you figure it out. Any questions at all on this problem? Okay, let me go back to Paint. All right, I think that's probably enough for examples. Again, I did a bunch of examples, and you'll get to do a bunch of examples in practice. So I want to give you the secret word. The secret word isn't really a word, it's a letter. And it's N. What does N stand for in this chapter?
Normal.
Normal. So that's our secret word for today. Okay, today was kind of a shorter one because this week, what are you supposed to really focus on?
Project.
The project, okay. This chapter is not the hard chapter. Most people have no problem with this chapter. It's the project that's going to be tough. But still, I want to remind you, don't wait until Sunday to do your work. That includes the project. It includes the assignment that's due on Chapter 6. Okay, it includes the discussion posts. You wait till Sunday and you realize you need more time, it's too late. So you should be really focusing on trying to get it done by Friday. And the project rough draft should be done by Wednesday, if you want me to read it. Okay, so what I'm going to do now is, as always, I'm going to open up to questions. So do any of you have any questions? Your chance. It could be on the normal distribution. It could be in your project, because that's what should be center of your focus right now. Any questions? Okay, if you don't have questions, you can say good night, but I'm always happy to answer questions. And if you don't have a project, you should be panicking right now. And I know the one person who's worried now has a project, so hopefully all the rest of you also have a project. I mean, a project partner. So if you don't have a partner, definitely panic and you need to get one. Any questions? Maybe I'll stop share so we can just see each other. But if you have any questions, I can answer them. If you don't, you can say goodnight.
I guess I do have a question.
Sure.
I'm getting limited responses on my project for sample.
So when you mean limited responses, do you mean from your partners or from the people you're asking?
The people I'm asking, because I'm depending on volunteers to answer my survey.
Uh-huh.
So I'm having a little bit of trouble getting them. What would be an adequate amount? Because I'm still trying to work.
Okay, you have to have more than 30.
Okay.
And we're going to
Sounds
learn that. And you don't need any more than 31, by the way. But I mean, if you get 32, it's not like going to take off. But whether you do 31 or 100, you're going to get the same grade.
Okay.
And 30 and 31 are very different. And next week is when we're going to discover why. There's the big theorem next week called the central limit theorem. But you do need more than 30, otherwise you can't do statistics. Literally, I have had students in tears in my office who weren't even my students, but they're getting their master's, and I tell them that their research is not any good. And not because I'm being mean, just because statistically you need a large enough sample size. And 31 is the absolute minimum. Okay. One of the things that I recommend is really look like a college student and tell them that you're taking statistics. Everyone will feel sorry for you and they'll answer your question. So that helps get people to answer questions because they want to help you because you're in a statistics class.
All right.
Does that make sense? That's
Yeah.
a suggestion I've got, is that it helps you get more volunteers. Is make sure you let them know you're a college student in this really tough statistics class. Please help. And they usually will. Other
Okay,
questions?
thank you.
Okay, great. And again, this is a great time to ask. So this is a good time to ask questions if you have them. Okay, and if questions come up later, you can always post in the project discussion forum and I will answer. I'll be checking pretty often. But it's easier when we're just talking to each other. Any other questions?
Thanks, Professor.
Yeah. All right. Good night.
Thank you. Good night.
All right. Thank you. And if you have any suggestions for the next week's webinar time and date, let me know. Otherwise, I probably will just alternate Mondays and Tuesdays. And for all of you who are watching this as an archive webinar, thank you for watching. Don't forget to post the secret word on the secret word quiz. So have a wonderful night.